Hi everyone, and welcome to lesson 2 from chapter 13. This lesson won't be quite as complicated as our prior lesson regarding the surface area of cylinders. Today we are talking about the volume of a cylinder, so how much of a physical object or physical space can fit inside of the cylinder. So we are going to skip past this video for today, and I'm just going to be teaching you how to find the volume of a cylinder. So we have 3 different cylinders here. We're going to start with this first one, and I'm just going to put them in this chart, but they're not most likely in correct order. And we're going to work on solving them. So the point of, or one of the main concepts that you're going to be learning from this lesson is another formula. And you may have noticed that, wow, it seems like we're working with a lot of formulas. Well, when we're working with surface area, we're primarily using formulas that we already know, like the area of a rectangle or a triangle or a square. If you don't know those formulas, it is important to memorize them. Now we're starting to add more formulas to our memory banks, and we have one that is going to be specifically for a cylinder. But the cool thing is, when you're working with volume of any prism, so the volume of any prism, there's one formula that works for all of them. And it's volume equals the area of the base, which we symbolize with a capital B, times the height. Okay, and this is for any prism. And the definition of a prism means that they need to have 2 bases that are exactly the same and parallel to each other. So, for example, we could have rectangular prisms. This might not be the perfect drawing because I'm drawing it digitally. But we could have rectangular prisms, or we have the base here, and then this would be our back dotted lines. And then we have the parallel base here. They're parallel to each other. They're the same size. But example of an object that is not a prism would be like a triangular pyramid, because while it is a 3-dimensional object, none of our bases are parallel to each other. So this is not a prism, it's a pyramid, but this is a prism. So whenever you're working with prisms, there's one formula that we can use. However, you are going to see that many people use different formulas for volume. So when I teach you these formulas, I'm going to teach you 2. I'm going to say area of the base times the height, which is still true, or I'm going to show you the other one, and you'll see what I mean by that in just a second. So let's go ahead and try this to find the volume of this prism first. Sorry, cylinder is the word that slipped to my mind. So we're going to find the volume of this cylinder. So I'm going to re-sketch this over here. This one gives us the radius of 6 and a height of 4. And then that same circle is on the bottom, and I'm not going to draw the back of it. Okay, so we need to find the volume of this. So we have 2 options. We can say volume is the area of the base, which is a capital B, times the height, or the formula is, specifically for cylinders, the formula is pi radius squared times height. Now we're going to take a moment here and analyze these, because if you notice, remember the capital B stood for area of the base. Well, what is the base in this situation, everybody? It's a circle. So this right here, pi radius squared, is the area of the base. So that's why these 2 are the same thing. So pi radius squared is the area of my base, and this capital B represents the area of the base. So these formulas will both give us the same answer. This one is just specific to cylinders because we specifically have a circular base. Okay, so we're going to move on, and we're going to solve this problem. So volume equals pi radius squared times height. So volume equals 3.14 instead of pi 3.14, times 6 squared times the height, which is 4. So I got the 6 from my radius here, and I got the height from I got the 4 here from my height. Okay, so let's simplify and reduce this. So 6 times 6 is 36. So now I have 3.14 times 36 times 4. And again, I'm just going to do this in my calculator. We could do it by hand, but just for the sake of time, we'll do it with a calculator. Times 4. So we get 452.16 is the volume of this guy. 452.16, and now we're working with volume, so it is cubic centimeters is the volume here. Okay, that's a very sloppy square. I'll undo that. Let's go ahead and find the volume of this one and practice again. So we have 4 centimeters as our radius and a height of 6. All right, so volume equals the area of my base, which is pi times radius squared, times the height. Okay, so pi is 3.14. Radius squared, my radius is 4, so 4 times 4 is 16, times my height, which is 6. All right, I'll type that in, and we'll get 3.14 times 16 times 6. 301.44. 301.44. And then I'd like you to try this last one on your own. See if you can figure out the volume of this cylinder. Pause the video now. Hopefully you had some time to take your best shot at that. So here we have the radius of 5 and the height of 5. And we need to solve. So volume equals pi radius squared times height. So volume equals 3.14 times radius squared, that's 5 times 5 is 25, times the height, which is 5. And if we type that into a calculator, we will get 3.14 times 25 times 5. 392.5. So 392.5. So we did not line them up in correct order when we first guessed, but that's okay. I think it was asking us from least to greatest. Yeah, least to greatest. So it would have been the 4, the 5, and then the 6, which it won't always be that way, but that's okay. 4, 5, and 6. Okay, it's your turn to try this one. They gave you the radius and the height. You should have everything else. And we'll talk about what this means when it says leave the answer in terms of pi in just a moment. All right, hopefully you gave that your best effort. Let's go ahead and talk about what it means to leave this in terms of pi, and then check to see what answer you got. So when it says to leave something in terms of pi, it means to not multiply your numbers by 3.14, but instead to leave the symbol, oops, I need my marker, leave the symbol pi in your answer. And we'll talk about that in just a moment. So let's go ahead and solve this, and we'll keep pi in the equation as long as possible. So volume equals pi, equals pi radius squared times the height. So volume equals, I like to keep my equations all lined up so I know exactly what I'm working on. Volume equals pi, remember we're not changing that to 3.14, pi radius squared, well radius squared is 100, 10 times 10, times the height, and the height is 12. So remember, usually I change this to 3.14 and then we solve, but we're going to leave it as pi. and we're just going to do as much math as we can. So we can do this math, 100 times 12, that's 1200. So we're going to have pi times 1200. And is there anything else we can simplify if they don't want us to touch pi? Hopefully you said no. So our answer is volume equals, you can say pi times 1200, or you can say 1200 pi. Now, the reason that sometimes they ask you to leave it in terms of pi is because pi is an irrational number that actually has an infinite amount of numbers. So if we were to do 1200 times 3.14, we would get this very precise answer. So I'll take a picture here. We'd get this precise answer. Okay, but if we were to actually do 1200 times, let me see if I can find pi on here. Here it is, pi. We would get this number. So see how they're slightly different? We have 3,768, and then we have this more precise number. And this number, if we could, would go on and on and on and on and on forever, because pi is an irrational number. So if we multiply a rational number by an irrational number, it also becomes irrational. So when we say 3.14, we really are estimating pi. We're rounding it to 3.14. So when you leave it in terms of pi, meaning that we leave pi in our answer, this is the most precise answer that we can give, because we're not shortchanging pi. We're kind of letting pi just be itself. All right, so when it says leave in terms of pi, multiply everything else out, but leave pi in the problem. Okay, here's our last problem. Let's listen to it.
For an art project, you plan to pour different colored sand into a vase with a volume of 47.5 cubic inches. You have 3 cylindrical bottles of sand. Do you have enough sand to fill the vase? Explain. Use 3.14 for pi.
All right, so that one, did you hear the difference? They said use 3.14 for pi. So it doesn't want us to leave it in terms of pi. So that means we get to actually do some multiplication here. So here's our problem. We are trying to take these 3 colored sands and pour them into this vase. And they want to know if there's enough to fill the vase. And the vase can hold 47.5 cubic inches. So as you read these word problems, make sure you understand what's going on. So we need to find out if all these 3 added together is going to be greater than, less than, or equal to 47.5. So let's find the volume. Luckily, all 3, the red, blue, and green, all have the same measurements, so we can just find one volume. So we're going to do volume equals pi radius squared times height. So pi. The radius is 1.25, because remember they gave us the diameter. Always take an extra look at that. Make sure they're not tricking you. 1.25 squared times 3.75 for the height. Let's plug that into a calculator and see what we get. So pi was 3.14 times 1.25 times 1.25 times 3.75. We get 18 let's round that to 4, 18.4. 18.4 is how much each of those holds. So if each one is 18.4, then we can say 18.4 plus 18.4 plus 18.4, or we can multiply 18.4 times 3, which is what I'm going to do, 18.4 times 3. And if this is greater than 47.5, we will have enough sand. If it's less than, we won't. It is 55.2, so the red plus the blue plus the green is 55.2. So yes, we have enough sand, because when I found the volume of all of the cylinders, there was more sand than the vase can hold. All right, we're on part 3, and friends, please don't be angry, but we do need to go over this problem in one extra video. So I promise it's only going to be a 3-minute video or so, So go ahead and pop over to that next video and we'll finish this problem and then be done with this lesson.